My name is Rene Rubalcava. I work with the JavaScript team and the apps team and do all kinds of other cool stuff, which is kind of neat. It's my co-presenter here.
Yeah, I'm Yann. I'm working with Rene. I'm part of the JavaScript team. I'm one of the lead on the JavaScript API 4. We're going to present you some of the fundamentals working with 4x, especially if you're familiar with 3, what changes, and we're going to talk about some of the layers, some of the widgets, cover a little bit of everything. It's kind of a getting started, but not so much, and also like working with API objects. So yeah, a little bit of everything. So this is the agenda.
What number are you?
Oh, yep.
3.
I'm 4, S3, yeah. This is our agenda, so we're going to cover map and view, BaseMap, ground, operational layers, some of the layers, kind of the main ones. Talk a little bit about layer views, widget UIs, the integration with ArcGIS platform. And then second part, we're gonna cover like more the programming patterns. So dealing with events coming from the view, working with the objects in the API, promises, loadables. So map and view. So in 3x, you create one map, and then that map holds on the layer, but also like where is positioned the map in the world, what is its scale, its extent, and so on. In 4, we adopted exactly the same paradigm as the same separation as the runtime API. So you have on one side you have the map, or you can call it a scene if you are working in 3D, but it's the map object. The map holds on, it's the description of your world, so it holds on all the layers, the base map, and the layers. And then on the other side, if you want to display that map, you need to either create a map view or a scene view. And so the map view is really where it's a window on that world, kind of. So this is how you create a scene view. Yeah, so this is what I was saying, like it's what the world is composed on, and the map view and scene view is kind of a window on that world. So we have, it's possible eventually to create multiple map views for a single map, for example. They will display the same data, but at different places. So this is kind of a like 10,000 feet architecture. We have a base view class. So if you look at in the SDK, you will have the view class, and then we have 2 main subclasses, map view and scene view. And then on the other side, we have the map that holds on layers. So the map has two subclasses, web map and web scene. So they are the classes you would create if you want to deal with a web map on ArcGIS Online. So you can create, the big difference is that the map is not loading anything, it's just like a container of the layers, whereas the web map and web scene, first they need to fetch the information about the web map or the web scene, and then create the layers based on what is in there. And I will talk a little bit about layer views later. So when you are dealing in 2D, you will deal mostly with map and map view, or with web map and map view. And then in 3D, it's going to be more like web scene, map and scene view, or web scene and scene view. So in 3x, we have all the layers are kind of together. It's not really true, but they are considered together. You have to see that the concept of BaseMap arrived during the life cycle of 3x, I think. There was no concept of BaseMap before, so you had to manage your layer differently. So in general, BaseMap has, we call that the sandwich. You have a base layer at the bottom, and then after you have all your operational layers your user is dealing with, and then you have a reference layer that is on top. It's really complicated when you want to create some user experience like a layers list, or you have to deal with, how many layers I have in my base map, how many reference layers, how many base layers, so that I can move those. So what we decided is to completely separate layers into individual groups. So we have a base map that contains that will contain the base layer and the reference layer, the ground that contains the elevation layers, and then the operational layers, which is more like feature layers, map image layer, and so on. So this is how you can create a map with a base map and a ground. So the ground is really useful only for 3D. You would specify the elevation layer that you want to use. So there are multiple ways to create those. So first, you can either use one of the well-known IDs that the API provides. So we have a set of base maps that you can directly create by referencing their name. So you have the street base maps. I won't say all of them, but you have like raster base maps like street and satellite. And then you have vector base maps. So we have a set of them. Under the hood, the API will rehydrate those strings into real base map objects. And then the same applies for ground. So ground uses Esri provides for free an elevation service, and so we called it world elevation. And then we will create the ground object with one elevation service in there. You can also create a base map by specifying the actual layers. So you instead of using a string, you pass an object to your base map, and then base map has two collections of layers. One is base layers, the layers that will be drawn on the bottom, and then the reference layers that are drawn on top. And the ground just has a layers collection. And then you can also create a base map using a portal item ID. So I don't know what is that item, but if you find a web map that has an interesting base map, you can just reference the item there. All our base maps are actually also items on ArcGIS Online, so you can copy one of these. Often the that team, the Urban Observatory. Which one? Like the content team release all the time new vector base maps, and then they you can grab their ID over there and then copy paste, and you get the base map from there. And then finally, the map layers really contains your operational data. You want your user to work with. Base maps are you can switch very often base maps like to give different context, whereas layers it's a bit different. Okay, so at any point in time, you can modify any of either the layers or the base maps using the collection API. So collection is a class. It's basically an array with some events and also different methods like that are not available on array. But you can directly add a layer to the base map base layers, or add many layers, or remove many, remove them all. Then the same applies for the reference layers, the ground, and the layers. The map has some shorthand to be able to add, like in 3x, like map.add layer is now in 4 map.add. So since they are collections, you can do fun stuff with the collection API, like filtering, for example. You can easily filter the layers that are in your map, and then provide a different collection. So yeah. Let me see. Okay. So on top of that, in the layers, you can also create group layers. It's a new layer in 4, which basically allows you to create a hierarchy of layers, grouping layers together. It's a layer that can be like toggle, like set their visibility off, so a whole group of layer might disappear. You can configure the group layer to say, oh, I just allow one layer to be visible in that group. So then when we turn on one layer, the other ones are turned off, and so on. So it's basically, the group is basically has the same API as the map. So you can do group.layers.add or group.add, add many, remove them. So same API. The same as in 3x, a layer can be only added in one place at once, so either in one group or in only one map. When you add a layer when you add a layer somewhere, we verify that it's not already somewhere else. In that case, we would remove it from its previous place. Yep. So the big difference with 3x is that it's much easier to swap a base map with another one. You can reproduce a tree structure with the group layer, and then yeah. But then the problem is like you can have like layers a little bit everywhere. So if you want to have a grasp of all of them, you can use this new collection called Map All Layers, which is a collection, a read-only collection, where you can see all the layers, either the ones that are in the base map and also in layers and so on. So it's very handy because you can quickly search for a layer that is anywhere in your map, in any group, just by using the collection function find. It's the same as the one on an array in the latest Arrays API.
And this is really useful too, because if you ever try getting all the layers in 3, there was like a few places you had to look in the operational layer or regular layers, I think, and you had to look in graphic layers and stuff. And it's pretty clear now where if you want base map layers, look in base map layers. If you want the regular layers, you can just get from the layers themselves.
Yep. Yep.
4, please. That should be written in French.
Yep.
So we're talking a little bit about the layers that are in the API now. So these are all the supported layers that we have in the API at the moment. So we've got all the basics in here: the tile layer, graphics layer, feature layer. Recently we got CSV layer in there. Just talked about the group layer. We have imagery layer, map image layer. Okay, so if you're not familiar with map image layer, this used to be called the ArcGIS dynamic map service layer in 3x. I don't want to say that much. I asked them to change it. He did. Very nice of him, right?
Yep.
Same goes for tile layer. The ArcGIS tile. We didn't want to add all that. We didn't need it. You know what you're using. We don't need to prefix it with our with ArcGIS. We got the OpenStreetMap layer, stream layers in there as well. We got the vector tile layer, web tile, GeoRSS layer. I didn't realize we had GeoRSS layer in there until recently. I was like looking for it, and someone was like, "We got that."
I think we just added it in a.
Did it just go for? Okay, see, so I wasn't being dumb. It wasn't there before. We have 3D specific stuff going on. So if you're working with 3D, so we have the elevation layer, which we'll talk about, integrated mesh, point cloud, and the scene layer. And we'll talk about some of the differences and what you might use those for and how they're used in a 3D environment. So the tile layer, I'm pretty sure most people here are familiar with it. I would say the tile layer is probably the most used layer, the one you don't think about in the API. It's what makes up most of our regular base maps. It's fast, easy to cache, and we can display them pretty simply inside a 2D and 3D environment. So this is how you can create your own tile layers. So if you've got your own tiles that you've published and you want to use those tiles, you can just give it the URL, provide an ID. This tile layers will also work if the tiles themselves are already their own size, but if you have their own projections. So if you're using a specific spatial reference and use a tile layer, just make sure that any other layers you're adding to your map are also the same spatial reference. So web tile layer. Web tile layer is pretty cool. Web tile layer lets you bring in non-ArcGIS service layers. So if, for example, we have the sample here that shows working with Stamen maps. So Stamen has a service out there for showing their layers, which are pretty cool. They have nice cartographic stuff that they do. And you just need to give us we'll call it a template. So tell us what the subdomains are, tell us what the level, row, and columns are going to be, and then we'll go ahead and we'll be able to decipher all that to display that. And if we just click on a little sample here, my God, it's cold in here. So this is the how we do this web tile layer inside 3D, and you can see it's a very nice looking map that they've got in here, and I can dig in a little further. And these tiles are just being downloaded directly from the Stamen services. We can display it pretty quickly because we're able to figure out where the tile is supposed to be coming from because you give us that little URL template to pull stuff from. So this is great. This works in both 2D and 3D. It's something that you may want to use occasionally. The OpenStreetMap layer that we have inside the API is essentially just extending web tile layer under the hood, and we just add a little bit of sugar under it to make that pretty seamless for you to bring in the OpenStreetMap data as well. And again, that works in 2D and 3D. Pretty much any layer that you use in 2D is going to work in 3D. I can't think of a case where it doesn't right now. I think you're good everywhere across the board. So graphics layer, I'm sure everyone here that has touched 3x at all is familiar with what a graphics layer is. It's the simplest layer to work with, and you can really just think of it as a bag of graphics. A graphics layer can hold points, it can hold polygons and lines all in the same layer. It can just be a mix of layers. And because of this, it does not have a renderer in 4 anymore. So you can't just apply a renderer to a graphics layer and everything show up the same. Every graphic that you add into a graphics layer has to have its own symbology to be able to show up correctly. You can provide, but the cool part is that each graphic can also have its own individual pop-up template as well. So if you need to do something weird where you may have multiple graphics shown on the map, but each of them needs their own distinct pop-up template for every reason, this could be a good route to go. So again, you can define a graphics layer a couple of ways. Well, it's just really just the one way. So you can either provide the graphics when you instantiate the graphics layer, or just add them the same way. And you can see this pattern start to come up in a lot of the way the API is built. So we've got a graphics layer.add or add many. We had a map.add, map.add many. It's a consistent API throughout, and this starts to show as you start looking at more of the samples. I could actually show a sample of this one. Let's show the 3D one, because the 3D one's cool. Everyone likes 3D. It's probably nice to show. And the visual points are cool in 3D, right?
Not everyone can use 3D though.
Okay. You guys will find a use for 3D. I'm confident you'll find a use for 3D. So this is how you create the graphic. This is like a one-shot way to be able to create a graphics layer. Now you give it the attributes, give it the geometry, give it a symbol of some sort. I'm just doing a simple mark symbol. It's not too difficult here. And then give it, if you want, give it a pop-up template. You don't really have to give it a pop-up template, but you do have to give us at minimum a geometry and a symbol. If you give us a geometry without a symbol, you're just not going to see anything on the map. Symbol, no geometry, we don't know what to do with it. So those two are the bare minimum you need to be able to display a graphic in the map. It's FeatureLayer. So FeatureLayer I would call the premier layer in the platform. It's used everywhere. It's used extensively. As Jeremy, our product manager, likes to say, if in a Fantasyland world, everything would be a feature layer. If we didn't have to worry about download speeds and size and everything like that, because it can just do everything. The feature layers are used from a feature service, which was initially intended to be used primarily for editing, but it's just become so versatile for everything that we can do with it. It's just used throughout the entire platform itself. So one thing with the feature layer that distinguishes it from a graphics layer is the fact that it's a single geometry per feature layer. So you can't just have a point and polygon on the same feature layer. It all has to be points or lines or polygons. That's consistent throughout there. The symbols, you cannot, if you try and apply symbology to a graphic and then add it to a feature layer, it's just not going to work. The symbology has to be defined at the feature layer level, is how you want to do it. That's used by using the renderers. So you initialize a feature layer, just give it the URL. Again, just how you can initialize any layer, and then the portal item as well. So if you have an item ID for a layer somewhere, it's pretty easy to bring that in there. And that portal API makes that pretty powerful to do all this kind of stuff. Feature collections. So this works a little bit different than you may have been used to if you did feature collection stuff in 3x. At this point, what you need to do to define a client-side feature collection for the feature layer is tell the feature layer what the object ID field is. We need to know what that's going to be ahead of time so that we can do any client-side queries that need to be done. Tell us what the geometry type is going to be so we know ahead of time so we can optimize for that geometry type. And then give us the fields. And this is really important if you want to have a pop-up template or some other renderer that's going to be field-based that you're going to be using for the feature layer, so we know what to do with the fields and it helps us in the queries. And then just give us a renderer of some sort. In this case, we're going to use a simple renderer with a simple marker symbol. We got pop-up template working here, and then we call it source. So if you're doing client-side feature collections, there's this property called source is going to be the array of the graphics that you're going to be providing to the feature layer itself. And those have to they really just need attributes and geometry, and then the feature layer is going to handle everything else about it. So that's how you would manage that. Now we get into the map image layer. So map image layer is really cool. And if you work with ArcGIS Dynamic Map Service Layer in 3x, some of the APIs on that were a little wonky. It was cool to work with, but it wasn't ideal to work with as a developer. In 4x, that's completely different. The map image layer API has been completely redone so that all of that kind of oddities that you may have to work with dynamic map services and stuff has been abstracted away to make a very clean API to do some really cool things. So if you're not familiar with the map image layer, it's available if you have ArcGIS server, and it will export an image of your map based on a bounding box. So just give it an extent, you're going to get a single image back, so it's not tiled. So it's still pretty quick. The file size is a little larger, but it's not really much of a big deal because you get this really great looking image that comes back that we can display for you. A benefit of that is if you're going to have a lot of data you want to display. So like with the feature layer, Yann was able to show the demo where we showed about 108,000 points in the experimental feature layer stuff that he's been working on. But the map image layer, make it show as many points as you may have in your map project that's been published. And we don't have to try and choke a feature layer to display that data. If you use a map image layer, it'll just give you an image of the data, and behind the scenes you have to bring all that data in. So it's great for doing large data sets. Dynamic map services, or the map image layer itself, has sublayers. So it looks like feature layers. So if it's got 0, 1, 2, 3, you can just define those sublayers when you create the map image layer, and you can control the visibility client side on what you want those to be. So you can define those here pretty easily with these sublayer objects in the sublayers array, and you can also define the definition expression. So dynamic map services do support definition expressions, so you can maybe say only show me the counties with a population greater than 10,000, let's go with 1 million people per county. Those are kind of small populations for counties, but it is still working. Send those definition expressions in, and you'll get a map image that'll meet that criteria.
Yeah, just one thing on that. So for example, the sublayers visible property in 3x, if you are familiar with the ArcGIS Dynamic Map Service layer, it's that layer has visible layers, which is an array of all the IDs that you want to show. And it's really complicated to manage because, yeah, it's like you have to, every time your user is unchecking a checkbox, you need to rebuild that array of visible layers. In 4, we change all of this because in the end, they are kind of layers inside that service. So when you change visible true to false on one of those sublayers, we recompile that list under the hood. And this is the same like for renderer, and automatically, if we need to, we will use dynamic layers on the service, and yeah. So.
Yeah, I forgot about the visible layers part. I've been in 4lab too long. That was a very difficult time for me with the visible layers.
Yeah.
So like I said, the renderer too. So you could just use regular renderers like you would use for a feature layer, give it to a map image layer, and we're going to convert that renderer to the object that dynamic map service is expecting for its rendering info or drawing info to be able to return back the map image layer you want. So essentially you can have, if someone published an ugly map that you want to use, you can make it a nice looking map in your application at that point.
I will show you some samples.
Oh, he's going to show.
Yeah. So the SDK has plenty of the 4x SDK has plenty of new samples about the map image layer. So here is one, for example. So it's using a service that is on sample server 6 here of the demographics. And then here we are always like defining the sublayers, but you can also wait for the layer to load and then modify find the sublayer, for example, that has the ID 0, and then just modify its renderer. So we can like define its title. The title will appear as Oh no, it's not showing up here. Anyway, then the renderer, for example, and then the visibility. Oh, it's not this one, sorry. Enters occupied using our need. Yeah, this one. So here it defines the title. The title is honored by the legend, the renderer, the definition expression, and then after you can define also the labeling info. All of those capabilities are already in the ArcGIS Dynamic Map Service layer, but the API is so complicated to use that it's not used basically. So we wanted to make that much easier to so that you can use it like much more easy. For the plenary this morning, I made like a bunch of demos that I couldn't show because of timing. So I made this one, for example, where I was defining a sublayer, and then when I apply, it automatically change the default rendering. And then I made this one also with a sublayer, with a first sublayer, which is just a simple line symbol for the country's outline. And then I was making Rene being the center of my rendering. But then at the time I had to cut some content, so this one got so sad. All right.
That's a great map. I want that.
Yeah. All right, so I will talk a little bit about layer views. So when you have a layer in your map, the map view or the scene view will automatically create the counterpart that will draw that layer on the screen, and it's called a layer view. So for each layer here, you will have one layer view attached to that layer in the scene view. So if you have multiple map views or multiple scene views or a combination, you will have like multiple layer views. So this is, like for example in 3x, the layer has this suspended boolean that tells you if the layer is visible on the screen and so on. This is actually done by the layer view. The layer has a visible true false, but you don't know if it's, for example, not in the scale range or something like that. So the layer view draws layers on the screen. For now, layers views has limited APIs. I'm going to show some of it, but one of the capability currently of the layer views are for feature layer views is the ability to query for the features that are drawn on screen. So the feature layer is just a point to the feature service, but the actual map view, the layer view inside the map view will actually fetch the features. So the features are all held by that layer view. And it gives information about rendering like suspension and so on. The elevation layer view also gives access to the elevation data that is displayed on screen. So there is a layer view per map. There is a layer view per layer in the map. So sometimes, like for example, if you try to render a scene view with map view, if you have a map that has an elevation layer, we can't draw the elevation in 2D, so there won't be an elevation layer view for it. So you will have always a layer view per layer in the map unless the layer view cannot be created, or for example the layer is does not support the spatial reference of the view, or the tile cache is not compatible with, in the case of a scene view, you need to have a tile cache where each LOD, each level, I'm going away in my explanation. So the base maps, LODs, each scale is divided by 2 every time you go from one level to another. You need to have a tile cache this way to be able to render in the scene view, or else it's not going to be able to render. 3D layer in the map view doesn't work also. So the same as the map, the map view and scene view have multiple collections of layer views. So this is how you can access a layer view. You can use it by with this function view when layer view, because when you add the layer view is not yet created. the MapView will listen for the collection change on the map, and then will figure out which module it has to load for a particular layer, and then so there is some asynchronicity going on. So you can do this. So you have the map and MapView. You create your feature layer and add it to the map, and you want to know when the layer view for this layer will be available. Then you get the layer view. Then you can do something like setting in the visibility of the layer view. Like in the map, you have map.allLayers, you have map.allLayerViews to quickly search for the current layer views for that are in the view.
Real quick, let me show
Yes.
Because I think I made that last slide from I messed up. One thing to keep in point when you're watching for, when you get the layer view, passing it the layer, and you get that promise back, before you start to work with the layer view and do any queries on it, you want to watch for when this updating property is false. So when the layer view is done updating, you've got all of the graphics available to start doing something with, meaning that you can query the features that are in the layer view at that point. If you try and do a query the features before the layer view is done updating, you're not going to get any results back, and it can be kind of frustrating. Just remember that part, because it's bitten me a few times in the past.
Yeah, so you can, for example, like here, getting the layer view for a feature layer and check if the layer view is suspended. So this would be true, for example, if the feature layer is not visible, or the map view is at a different scale that is not supported by that layer. So feature layer view can be queried. Like you have. So in 3x, you can do feature layer query features. The query features on feature layer in 3x ask first if it has looks first if it has already the feature on the client. If it's not, it's going to go to the service. In 4, it's different. When you go feature layer query features, it's always going to the service. But then if you ask the features on query features on the feature layer view, now it's going to query for the features that are displayed on screen. So it's very handy if you want to get the extent of all the features that are displayed. This is how you would do that. Do you have an example on a query feature?
No, not a good one.
All right, so we get the layer view from for this feature layer, and then we create a query with the view extent, and then here I would do query features with that query and get the features that are in the view extent. Widget and UI is for you.
All right, catch up here. All right, so widgets and UI. Let's talk about some really cool stuff out of the box here. So at 4.3, actually this list I think is a little outdated at this point. These are a list of all the widgets we have there, but we also have print. We have a scale bar, because people like scales. Only works in 2D, by the way. All these widgets are really cool. They've all been rewritten from scratch. So when 4x started, the decision was made that we were just going to completely rewrite all the widgets from scratch, build them all up, and work pretty closely with our UX, UI team, our Creative Lab guys to come up with some designs on the widget and make sure that we're developers, and I think we got a good eye for a lot of good stuff, but even like our guys that work on the widgets work pretty close to these other guys to make sure that the margins and stuff looked really good, and that'd be kind of a good experience for other users. So one of the other big things that we did, and I kind of showed this in a plenary this morning, is extensibility of the widgets via CSS. So it's pretty easy to modify a little bit of CSS and change the theme of the entire application. So if you look at this sample here, cross my fingers, works? Yeah, awesome. So the actual map being shown has a lot of dark grays, black, and this light red colors in here. So I wanted the UI to match what my map had, right? I'm kind of trying to keep everything coordinated and cool like that. So you basically modify a little bit of the CSS here. We've got this all laid out too in the documentation. It shows this. You can create your own custom theme. And when you create that theme, you just apply it to these Esri CSS classes, and it'll just change all the UI for you. And that even should include Cross my fingers, pop up. Yes, that works too. So that works for across the board for all the widgets. So the guys that worked on this stuff were really careful in terms of how they designed the widgets and built the widgets to make them very extensible for the developers to be able to kind of do these custom UI enhancements. You can also do some really cool stuff if you've got fantastic looking custom styled vector tiles that you've done on your own that you want to show off to everybody. And you're trying to get a major sports organization to recognize you in some way or another. You can customize UI to match out your application as well. So in this case here, we have a glorious purple and gold and the glorious purple and gold UI to match those vector tiles. So this goes hand in hand with maybe branding that you might want to do for your organization, kind of stuff. You can just kind of theme out everything as well. It works really good.
I think, yeah, the API also come with different styles out of the box. They are on the SDK.
Yeah, we've got, let me see here if I can find them. If you go to samples here and you search for themes, we've got a sample here showing you, I believe this is going to be a dark theme. And we have all these other themes that are currently available right now. We have a light blue, dark blue, and so on, all the way down to red. This is, and all you need to do to use one of these themes is to use the CSS file. So it'd be Esri themes / and then whatever theme name, and then the CSS file name. That's all you gotta do. That's all you need, and it will do the rest of it to update all of the themes for the widgets and the UI and everything else. So it's pretty easy to use.
And the team really made sure that creating new theme is just like changing like 4 or 5 colors, and on some selectors it's really small, and then recompile the SAS file, and then you get a brand new theme. So that's
yeah. So that was the next thing too. We provide the customs, the SAS files that we use internally to build our CSS. We provide those for you if you want to take those SAS files, modify them, integrate them into your own SAS files or some other workflow. Those are available in the Bower repo that we put out. We have a nice little guide on using the SAS files in here as well. So if you want to do that, you can always do that too. How many people here are using SAS, maybe Stylus or something like that? Cool. All right, awesome. That's quite a few hands. Awesome. Yeah, we use that in addition to PostCSS too, so we're all over the place. View models. So let's talk a little bit about the view models in here. I'll show that in a second. So basically, I think this next slide talks about more. You see this other theme kind of going through, where we have the map and the view, where the map is a data model for our views and stuff. So we have the same kind of architecture working with the widgets. The widgets are essentially our view that you get to use and interact with. But behind the scenes, what powers those widgets are actually the view models that do all the business logic. So for example, when you work with the zoom widget is just a button that listens for an event that says, call zoom view model dot zoom in or zoom view model dot zoom out. That's a really simple case, and other widgets like the search widget and a few more are quite more complicated, like the layer list or legend are more complicated widgets with more complicated view models. But it sets to separate that logic and the separation concerns to be able to modify what we need to modify at any time. It also provides an opportunity for us to give you the source code for the widgets themselves. So if you go in the SDK, every widget in the SDK, such as the zoom widget, is going to have this link here out to a .tsx file. And there's a couple of .js ones I think left at this point, but most are TypeScript files now. And they're going to take you out to the Bower repo, where we actually push out all of our source code for the widgets unminified. So if you're familiar with the Bower repo, it's all minified code except for these source files for widgets. So you can go through here, and we do this so that you can see how we build our widgets using the view models. This way you can take that view model and then maybe build your own widgets for it after the fact if you're using another framework, or you want to do some sort of a cool Franken widget, like I did this one here where I built that. Oh, this one's not going to work, I don't think. This is an old sample. But you can basically combine all of these, those old samples. You can basically combine these view models however you want. Maybe create a single widget that is going to maybe have 3 view models that do something like the home, zoom, and maybe some other work with the compass widget as well, and maybe the location widget to track stuff. We gotta hurry, huh? Oh, I'm gonna hurry up. I'm gonna faster now. All right, so the UI. So the UI in the map views, or it's in the scene view as well, it's an area in the view that you can use to add your own components and widgets, even a logo, something like that. We have this padding, which you'll see us abuse all the time. Basically, you could do something like if you have a header or a footer in your application, but you kind of want to see the map behind it, you can add this padding so that it will maybe be transparent, but all the widgets themselves will actually kind of move and offset from the map. And you can see a nice sample of that, if I can find it here. Here we go. So here's the convention center. We see the convention center nice and centered here. If I wanted to open up a side panel for some reason during my application, I can open my side panel and the whole convention center is going to move to the side and it'll move right back. If you turn off that padding, and let's say for example you don't apply any view padding at that point, and with the panel you can see that the map does not move. So you can see what that difference is when you start moving the map around. If you use the view padding, it's going to keep the center of your map at all times. I know some of you got that. So once you've got your widget or you have any component, you simply add it to the UI using the add method. There's a couple of different, you look at documentation for the different ways you can do it, but the basic way is first parameter will be the component. This could be a widget of ours or a DOM element, and then just the position. And we have different top left, top right, bottom left to add it to.
What is really nice about the UI also is that it's aware of the size of the view. So different widgets will have different look. If like the pop-up, for example, when the view is too small, it's gonna dock automatically to the bottom. So the view UI has you can watch properties like the orientation, if it's landscape or portrait, and then we have like breakpoints so that our widgets can have different aspects and depending of the size of the view.
Yep. All right, pop-ups. I'm going to go over pop-ups pretty quickly because we're kind of running out of time here. But you guys, everyone here has worked with a pop-up in the map because it's first entry point to your data. I mean, you always get a map, you click on it. We made the pop-ups a little bit simpler to work with. So you just give a pop-up template that's an object. You don't need to create a new pop-up template anymore. Just give us an object that looks like a pop-up template, and it's going to work. So we did change the little curly brackets from being a $ curly bracket to just regular curly bracket. I think that was the way we did in 3x, so that's a little simpler to remember now. Fields and aliases, so you can provide field infos for the pop-up. And I think this is pretty similar to the way we did it before. We give the label, we have a format, so you can do digit separators depending how you want the numbers in your pop-up to work. Format dates, so we have some out-of-the-box ways you can format the date, short date, long date, and I think there's a third option for dates, I can't remember anymore. But you basically just do that if you have a date field somewhere in your data. Custom content, so the content could just be HTML. Just define whatever HTML you want to be in there, and then use the brackets to placeholders for the field names, and it'll display that inside the pop-up for you as you want. Charts, you can do charts. There's a whole lot of different options for charts. If you check the doc on pop-ups, you can do pie charts, bar charts, column charts, scatter charts, line plots, I believe. You can't do scatter plots. You can do line charts though. In there. There's a few different themes too if you want to wear. There's a whole set of themes you can do for them, and they're based off the DojoX chart theme settings. So you can always use that. Custom actions. This is pretty cool. We kind of showed this, we'll layer this earlier, but we're sprinkling these custom actions in some of the widgets in the future. But for example, Popups has it, so you can have a custom action where you have an extra button next to your zoom button, and when you click on that button, something happens. And you have access to the feature that was associated with the pop-up when you clicked it. So you can pull the attribute data out of there, do something with the attributes. You can pull the geometry from that feature, maybe use Geometry Engine to do something with that geometry, and then repopulate the content with some other data, or pop up some other add features to the map. It's a pretty cool thing to do. This is a case here where you're doing a request to pull out some information based on the attribute data to maybe a third-party API. And then at this point, I'd probably have like a side panel or something else pop up with the information I get from that other API.
Yeah, it doesn't solve all the use cases, but before you had to create your custom pop-up complete component to just add a button for contextual actions. And right now it's like, it's made a little bit easier. The layers list also has that. If you want to have for this type of layer or this specific layer ID, you want to display a button to do something like change its opacity or so on, you can just create a little action.
Yeah.
Like this. So yeah, I'm going to talk about the platform integration. One of the key things one of the big user of the JavaScript API is the MapViewer on ArcGIS Online, and we plan to redevelop a new version of the MapViewer at some point once we get a full web map support in 2D. And we want to make sure that all the logic to author web maps and read web maps is well handled inside the API, directly inside the API instead of done by the application. Currently in 3x you have a method to load a web map, but we go a little bit further this time. So we have redesigned a new API for talking to the portal also, so getting the content from a user and so on. You can query for users, groups, and so. For example, you can load layers, web map, web scene, and then you can create and update and delete items. So concretely, the way it works is you can, for some objects like BaseMap, web map, web scene, and layers, you can specify a portal item with an item ID. Eventually, also you can pass a portal object. So if you have like layers from different portal, you can pass a portal, and then it will load the item from the specified portal. The default one is ArcGIS Online. So this is how I create a web scene. I specify the web scene ID, and then it's gonna load, do its magic. And then one important part also is that sometime in the web map or web scene, you have layers that are referenced. So they reference, they have an ID, and then we load an extra ID for that layer. So if I'm on ArcGIS Online and then I customize the renderer or the labeling for a particular layer, I can save that layer, not just the web map, just the layer, and then grab this ID and bring it directly to my app. With layer from portal item, I pass the ID and, for example, the portal here, and then it will create either the feature layer or whatever layer it is, and then I just add it to my map. So this is an example of using the new portal API. So you create a portal, you ask for the user to directly be asked for signing in, and then when you load the portal, and then when the user is signed in, you would create, for example, a query. You would query for, whoa, just stopped here. Yeah. You would query for the item for that particular user and just call query items. All right, second part, programming patterns. So this is Rene. Yeah.
All right, awesome. I'll try to get through this pretty quick. So basically, this whole bit here is we refer to this as input manager. It's basically working with events in the view. If you haven't noticed till now, we only really had like a click event on the view that did a few things. We've got real events going on in the view now with using the on method, things like drag, double click. There's a sample in the API. If you come over here, look at samples, it's pretty quick. I think I just searched for events in here. Yeah, so access features of click events. So you can actually do click events in here. Actually, there's a better sample in here on, let's see. Watch buffer 2.3, that wasn't it. I can't find anywhere. There was another cool one you could do with WASD, up and down and side to side in the scene view. That is a sample that's currently in the API. You can find that one. You can listen for drag events and so on. And these are all documented in the API, the kind of events that you can listen for. Sorry, we do have a list of events here. So these are all different events that we do support now. So we got the click, double click, drag, hold, key down, key up. And a lot of these were in place so that we can work in 3D and 2D with the consistent API across. without having to do some weird stuff behind the scenes to make things work for you. So this is how you can do a basic click event. You're going to get the XY on there. It turns to a screen point, and when you get the screen point from the click event, you can then use the hit test to do a hit test on the view to find out what graphic is going to be currently under that view. And yeah, this is how you can pull the results for that graphic out. And we have a sample in the API that shows you how to do that.
Okay, working with API objects. So this is very general. We simplified in 4 how you deal with properties on objects. In 3x, you have to know basically every single function, like how do I get the scale on the map? For example, the map extent, you do just map.extend and you get the extent. But scale, no, you have to do map.getScale. And the only way you know all of this is just to learn like all the API and have it in your head. So we want to we simplify that by just like, oh, I access the view.scale or view.extend is going to be the same. So objects in the API have properties. They can be read or set, read or set. They can be read-only properties. We can pass all the properties as constructor arguments, and they are watchable. So you can watch for the extent, for example. So this is how you access properties like layer.opacity, layer.title, and this is how you set them like very easily. You have additional functions like set, where you can pass an object with key values. And then you can, there are some sugar, like you can do get with a dotted property. So getting the title of the base map can be done like this instead of doing map, and does my map has a base map? Yes. What is the base map, the title? Now I can just like call like this. And this is how watching property, so you would use it. So watching means that I want to be notified whenever the property change on a particular object. So here I want to watch whenever the scale changes. So I will watch the scale, and then I will get, I pass as a second parameter a callback that will be called with the new value of the scale, the old value, the property name, and the target, which will be always the map. But, yeah. I can watch also a deep property like this. So whenever the base map change on the map, my watcher will be called with the new title of the base map. I can watch multiple properties with a single callback. And then also in the API, we have watch util in Esri core package that has lots of shorthands functions, like for example, when true, I want to know whenever the view stopped moving, so it's called stationary, that property. So I would just call when true, and then my callback here will only be called whenever the view stopped. Yep. So this is that that module. It has like when false, when not once, and so on. We simplified how you build objects. Instead of having very long constructors where you have to remember in which order are all the parameters, you pass one single object in any order you want, and then it just works. We also simplify, so as a side note, we removed a lot of those enumerations, and instead we have like well-known strings. We removed, for example, if you deal with different services in ArcGIS, you would see that you have multiple units of meter, but there is actually 1 meter. So in all of these APIs that accept a unit, when you say meter, it's meter everywhere, and you don't have to specify the unit of this particular service or task, and so on. So kind of easier. Color, for example, can be created with the CSS values or a color object if we want to. Right. It's you? Yeah.
Yeah. All right, awesome. So promises. I promise I'll be quick. This promise is used throughout the API a lot. Anytime we have any sort of async function, we have to wait for something to happen. So if you're not familiar with promises, they work this way. It's actually not probably the recommended way we do it anymore, where you pass 2 functions in, a resolve function and an error function. You actually only want to pass a resolve function, do a dot otherwise, that'll catch any errors in there, because when you do promise chaining, the otherwise will catch the errors in any part of the chain up above it. And I think we have may have a chain in here somewhere. So classes like map are promises, view is a promise. It's just used a lot. So if you want to work with the UI, like the stuff I showed earlier, you want to do view.then, and then you can start adding components or DOM elements to the UI at that point. Because if you don't, the UI may not be ready at that point, and you're going to get like, add is a function of undefined. So if you do view.then, when that's complete, then the view is ready to go and it's available on the page to start working with.
So yeah, sorry.
No, go ahead.
Okay. Yeah, so we replaced, like in 3x, you get a layer, your function gets a layer, you have to check what is my layer loaded? No, it's not loaded, so I have to listen for the onload event and then do something. Like now in 4, you can just do layer.then, and then you don't know if the layer is already loaded or not. You just don't care.
Yeah, exactly. It works out pretty nice when you get used to it, start working with it. The patterns that you start doing with promises are pretty cool. So this is how you do some promise chaining. So I do a when layer view. I find a layer from the map, and when that layer view is ready, I can do watch utils. So I mentioned this. We'll watch when updating is false. So we have that watch utils watch false once. When it is false, then I get a result back, and I can get that layer view, and I can do query features in layer view, return the result of the query features, and do something with that. And then I got this otherwise method here that if anything went wrong in any of the chain here, I'd get the error handled in my otherwise method down there. So this is how you do chaining promises throughout the API. Loadables is something new to 4x. It's something that like the runtime does. Basically, it's really cool that we are able to schedule loading of the resources in the API. And this is what lets us do something like load a dozen web maps inside our application without actually downloading all the data for those web maps. The same thing goes for the web scenes. We're only going to load all the data needed to draw when we need to load it to be able to draw. We're not going to load it ahead of time. So they're loaded, they're web map, web scene. So when you think about it, so a web map and a web scene, when we load them, we need to load the portal item. So we get the portal item, and it gives us all the information about the layers. Then we have to load the layers that are from the portal item. We got all that information. And then we have to load more details about the layers once we got the layer itself to be able to draw the layer. All right, so that's a lot of different steps, and you don't want to do all that stuff at once because it's too much happening there. This really lets us control when we want to load all those resources. And the same thing goes for the map view and the map. I mean, it's going to load the map, and it's got to load the layers and go through the same steps as above. So if you have say you don't want to use a map, so you don't want to display the map, you only care about the data that's in the map. You can do something like load the web map, use the load method, that's going to return a promise. Then you get a layer off the web map, you know the layer name. Load the layer, and when the layer is done loading, you can query features on the layer, get your features from the layer, and then do something with them. Maybe display them in charts, display them in a table or something, generate a report. But you can do all that by accessing the web map without having to ever display the web map on the page. And so it's a great way to be able to work with the resources. And all this is possible because we have that whole portal API backend inside the JavaScript API to do all this stuff. Oh, hey, there we go.
2 minutes.
I thought we had this session was really like a 9-hour training session that was put together at one point that we condensed down here for us. So if anyone's got questions, we answer a couple. Yes. Yeah, Yann.
Oh, kidding me. So it's a recurring question. So that's why it's a good question. Well, that's the thing. Like we have in 3x, it's just not possible like to combine widgets together. Whereas in 4, now that we have those view models, we can eventually combine them. Like Rene was saying. Together, like I have a legend that is configured for each layer, and then combine that into the layers list. Out of the box, it's not planned currently, but we never know.
Yeah.
For now, yeah.
Someone has made it. I've seen someone make it on their own. It's on GitHub.
There is. Let me pull up the.
I'll put it to you.
Yeah.
While he's doing that, any other questions I can answer for you real quick? Yes, I saw a hand over here.
Transparency opacity, is it in the dynamic maps
Yep. The map service, so in the map image layer, each sublayer has an opacity. So you can control the opacity, the visibility, the definition expression, the renderer, the data source of the sublayer.
Yeah, we didn't even talk about the data sources for map image layer, which is really cool. There's a sample in the API that shows table data sources for map image layer, which is awesome.
So this is this one. It's called ArcGIS Redux, React Redux Legend, which is like a kind of a layers list with a legend baked in. It's an open project. Yeah.
Any other? Yes, I saw a hand over here somewhere. No?
Yep, sorry. Yep.
Any other questions today? No? This session does repeat on Friday if you fell asleep or left. Tell people that left that it repeats on Friday.
Yeah.
Thank you.
Yeah. Thank you.